Hello there, and welcome to this video lecture on heat integration, pinch technology, minimum number of utilities, minimum number of heat exchangers method, part 3, constructing a temperature interval diagram. Reviewing the 6 steps in heat integration, we've completed steps 0, 1, and 2. We are now moving on to constructing a temperature interval diagram, and the example that this material is based on is presented in the pinch technology chapter of the Tout textbook. Our first step is to list temperature cutoffs, adjusting for minimum approach temperature. And I've put here our table that we've constructed in the previous step, step number 2. Our first step is to list all of the hot streams inlet and outlet temperatures shown in the table. So we're going to look at all of these red inlet and outlet temperatures, and we're going to list them in a table under hot. Notice that for duplicate temperatures such as 150 degrees or 50 degrees, I do not list them twice. We subtract 10 degrees for minimum approach temperature, and then we list these temperatures in the cold column. Next, we do the same thing for all the cold streams inlet and outlet temperatures shown in the table. So notice that we have some duplicates that are already in the table. A lot of them are duplicates. The one temperature that's not a duplicate is 90. So I will list that in the cold column, and then I add 10 degrees to that 90 degree temperature for the minimum approach temperature for the hot side. Our next step is to lay out streams with their flow rate times heat capacity values horizontally, and then we will lay out our temperatures vertically. And notice that I have put here a little icon in the upper right-hand corner as a reminder of all the temperature cutoffs that we calculated on the previous slide. So what we do is we list each stream from left to right with their number and then their flow rate times heat capacity. And then we're going to lay out these temperature cutoffs vertically. And notice here I'm going to draw some lines which break these blocks up into A, B, C, and D. And these are just based on the temperature cutoffs. Also notice that I tried to draw these temperature cutoffs to scale, so I tried to leave more space between 300 and 200 versus 200 and 150. So we have 4 main blocks now on our temperature interval diagram. Next, we're going to draw arrows to represent the inlet and outlet temperatures for all streams. So these inlet and outlet temperatures come from the table that we completed in the previous lecture. The last step is to calculate the overall Q for each block. And so this is the flow rate times heat capacity times the inlet minus the outlet temperature for each individual block. So we're going to start from the top in block A. So block A on the hot side has 1 stream. So its flow rate times heat capacity times T in minus T out is 8 times 300 minus 200. For the cold side, we also have 1 stream. Its Q is 5 times 190 minus 290. Notice that this is a negative number. So when we add both of these together, we have 800 minus 500. This is a resulting Q for block A of 300 kilowatts. Let's move on to block B now. We have 2 streams that we are summing on the hot side and 2 streams on the cold side. These are their flow rate times heat capacity times delta T. On the cold side, we have this for the flow rate times heat capacity times delta T. We sum these 4 Qs and we get an overall Q of minus 50 kilowatts. Let's move on to block C now. Again, we have 2 streams on the cold side and 2 streams on the hot side. Starting with the hot side, we have these flow rates times heat capacity times delta T's. and on the cold side we have this for our Qs for each of those streams. We add these 4 and we get an overall heat for block C of minus 350 kilowatts. The last block is block D, and we have 2 streams on the hot side, we have 1 stream on the cold side. This is the Q for the hot side. The Q for the cold side is shown there. We sum these 3 and we get an overall Q for block D of 50 kilowatts. So just checking our work here now, if we were to sum all of these Qs for all of these blocks, we get again a deficit of minus 50 kilowatts. So we know we performed our math correctly.